So this is video number 5. And this is another sort of single reactant stoichiometry problem. But this time we're quantifying energy and heat. So we have seen this before when we did bonds broken minus bonds formed, and we got a number. And we talked about what does that number represent. And that number can represent the amount of energy that's released in a chemical reaction or the amount of energy that's absorbed in a chemical reaction, right? And if it's energy that's absorbed, you can kind of think of that energy as a reactant, as a necessary component for the reaction to happen. This is how much energy must be added for the reaction to happen. If that is the case, we know the reaction is endothermic, and we will see energy. Energy will have units of kilojoules. It could have joules. I think every time in this chapter it's kilojoules. That's the unit that is that we use for energy or heat. If it's an exothermic reaction, then energy would be considered a product. And that means that we would see those kilojoules listed right in the balanced chemical reaction on the product side. If it's an exothermic reaction, it's the energy's on the product side. Endothermic reaction, energy is on the reactant side. So what this tells me now is that when 1, so the coefficient of N2 is 1, when 1 mole of nitrogen and 3 moles of hydrogen react, 2 moles of NH3 will be produced along with 92.4 kilojoules. We're actually quantifying now the amount of energy that is released. And of course, it makes sense that if 1 mole of nitrogen releases this much energy, then if I have more nitrogen than 1 mole, I will release more energy, or less than 1 mole of nitrogen will release less energy. And how we actually get a number for that is by doing a stoichiometry problem. So the stoichiometry problem here says how many grams of nitrogen, right? Circle the do. Are needed to produce 150.9 kilojoules of heat, right? I underline the clue. That's the number that goes out front, 150.9 kilojoules. That's a lowercase k and a capital J, okay? So now we do, like we do for all our stoichiometry problems, we make a parenthesis. Now, what is going to go in my parenthesis? Well, if this unit is kilojoules, diagonal down must match. So I'm going to use this number, 92.4. And right away, we need to start thinking about what do I want to find, right? Look at what I circled, grams of nitrogen. So I am relating my 92.4 kilojoules to 1 mole of nitrogen. So 92.4 kilojoules will be produced when 1 mole of nitrogen is reacted. The question says for grams of nitrogen. Well, we know this. In order to go from moles of nitrogen to grams of nitrogen, I need to use the molar mass. 1 mole of nitrogen, and from the periodic table, 28.02 grams. Right, checking my work here. Kilojoules units will cancel, moles of nitrogen will cancel. The only unit that is left is grams of nitrogen. And I plug this into my calculator, multiply 150.9 times 1 divided by 92.4 times 28.02 divided by 1. And then I check for significant figures. This number has 4, but my 92.4 only has 3. And that does count because that had to be measured. The way that we would measure that is through a process called calorimetry. We'll do that in AP Chemistry. So my answer is to 3 significant figures. Ooh, that's wrong. 45.8. 45.8 grams of nitrogen. So yeah, these problems are often actually smaller than some of the stoichiometry problems that we have done. Okay, how many kilojoules of heat, that's the circle to do, are produced when 59.7 liters of hydrogen gas reacts at STP? So 59.7 liters of hydrogen gas, right? If I want to relate hydrogen gas to liters of hydrogen gas, or just hydrogen gas in general, to energy, right? I am going to need to convert to moles of hydrogen gas, right? So I know 22.414 liters of hydrogen gas is equal to 1 mole of hydrogen gas. And then in my next parenthesis, I know that 3 moles of hydrogen gas are used to make 92.4 kilojoules of energy. So in the same way that it was before, the only time that we use the coefficients from the balanced chemical equation before were when we were going from moles of one substance to moles of another substance. Now it's when we're going from moles of a substance to energy, because the balanced chemical equation relates moles and energy. So what a lot of students have a difficult time understanding is, why did I use 1 mole of hydrogen here and 3 moles of hydrogen here? Well, the fact that 1 mole is equal to 22.414 liters, that is independent of this balanced chemical equation. That is always true. But in this particular instance, in this particular reaction, 3 moles of hydrogen gas will react to produce 92.4 kilojoules. Looking at significant figures again, this number has 3, so my answer is going to have 3, and that comes out to be 82.0 kilojoules. Liters of hydrogen cancel, and moles of hydrogen cancel. The last one here, how much energy is released when 6.49 times 10 to the positive 22 molecules of nitrogen are produced, right? Circle the do, underline the clue. So we have 6.49 times 10 to the positive 22 molecules of NH3. Of course, the first thing that I need to do is convert from molecules of NH3 to moles of NH3, right? That's Avogadro's number. And now, right, I can get to the energy part. So if I go back to the energy and look at the balanced chemical equation, let me erase this, right? That 2 moles of NH3 will produce 92.4 kilojoules. So now we have 2 moles of NH3 will produce 92.4 kilojoules of energy, right? Check my units, molecules of NH3 and molecules of NH3 cancel. Moles of NH3 in the numerator and moles of NH3 in the denominator cancel. So the only unit that I have left is kilojoules. That's what, get out of there. That's what I want. Significant figures. This has 3. So my answer is going to have 3, and that's 4.9, oh, I lost it. 4.98. Come on, you can do it. 4.98 kilojoules of energy. Okay, so you notice these ones are relatively simple. They are 2, maybe 3 parentheses if you're using density in there. The big highlights for this are just that, where do your numbers come from in the parentheses in our conversion factors? It is the coefficients from the balanced chemical equation relate to the energy. And energy does count for significant figures. Okay, so we did 3 problems today. If you go to the homework packet, what are we doing for homework on this? Okay, we've done up to number 16. You can see that the next headline here says add heat. So we're doing 17, 18, 19, 20, 21. Okay, so up through number 21 today in your homework packet, answers will be online. Check those off and then attend the next, this will be Thursday or Friday's seminar or Q&A time to ask questions about this. After this is also when you can begin the first video assignment that you're turning in. So there's information about that in Schoology also. You're going to write a problem on your own, solve it, and do just exactly what I do. Explain to me how you solve the problem. Any questions?